All right. Good day, everyone. Thank you for attending this session. We're going to talk about simple DevSecOps with GitHub around security. My name is Sanjin. I'm head of development at Solidify. I work as a DevOps specialist, DevSecOps specialist, and my mission is to create better software, so I'm part of OWASP as well. This is today's agenda. We're going to talk about the state of application security. We're going to talk about how to protect from supply chain attacks. And the last thing we're going to cover is how to protect our own code from introducing vulnerabilities. Help ourselves, basically. All right, the state of security today. Everything is good, everything is green, no problems at all. No. I mean, we write a lot of code, and this is a natural thing. We have features, we have new requests, and we write code. But we love using packages. We love using other people's code from GitHub, from open source community, which is totally fine. This is normal. But this is the state today. We have 80% plus of deployed code, which is basically made by other developers. And this is code we don't know that much about. So usually you go to Stack Overflow, you have some question, and they're like, I have a package for that, and then you use it. But in many cases, we honestly don't know much about it. So while we have in many organizations big structures about security, how to do that, 80% of deployed code plus is not ours. And then, of course, employee error. I mean, nobody wants to introduce security flaws. You do that because it's a mistake. Maybe you don't know. If it's a secret, maybe you missed, and it's in the Git, and you're there. So it's easy to do a mistake. At the same time, I mean, this is normal, right? We have more and more code, but we did invest billions of dollars into security, and we still have a situation where 85% of the code contains a vulnerability. And this is a scary number because there is huge investment, but we don't. Did we get better? What happened? So basically, the code we wrote 2020 was as good as it wrote in 2016. I mean, we did a lot in between. So this is one thing that we need to do is truly shift left. So previously we had shift left done in the building when we build the code for each commit, run unit test for each commit. We do a deployment in many cases for each commit or each pull request. And now we do want to do the same thing with security scannings as well. And this is where GitHub delivers this quite nice tool, which is focused for developers. It's aimed to developers. It's native to GitHub, and basically that's a tool I use almost daily. So this is the tool I actually have a focus on, and this is where the scanning will happen. And on top of that, there are some features which are highly automated. So best case scenario, I can turn this on with a couple of clicks. Best case scenario, Dependabot can actually open up pull requests for me and help me actually mitigate the problems I have. So if you look at the current capabilities of GitHub around security, so we have, as in the beginning, as I said, supply chain protection. We have a code protection, and then we have development lifecycle policies we can turn on. So for supply chain, we have dependency graph. So that's the first thing we need to understand. What kind of dependencies do we have in our project? Second, we do want to get alerts for all the vulnerabilities that have been found in the packages. And then there are features that we can utilize to actually block or fail pull requests if we try to introduce dependencies that are unsafe or that include license policies that we do not want to use as well. And this is an important thing. For the code part, we have secret scanning. It's a quite simple but very effective functionality. Basically, regexes that scan our commits, our pull requests or pushes and pull requests for secrets, which are basically patterns. And then we have a code scanning, where we do static analysis of the code to find vulnerabilities. And in true GitHub spirit, the tool that is used is open source and is large community around the queries. For development lifecycle, it's a branch protection rules. I mean, this is something that most of you already use. Make sure that you have a pull request for each commit to master or main. Make sure that you run specific actions and so on and so forth. And the last thing is commit signing, that we want to make sure that only specific people or that we can verify that the correct people have committed the code. So let's go into the supply chain. I mean, most of you have heard about Dependabot. Certain Dependabot feature has been available for a long time. So what Dependabot does, it looks for the dependency view, dependency graph, and checks the databases for the vulnerabilities. And if it finds vulnerabilities, it will actually alert us. And based on the configuration, you can get alerts on the email as a digest. You can get it in GitHub. There is a multiple sources how you can receive this information. I will focus on the parts that are inside the GitHub, inside the repository view where you usually work. Another thing that Dependabot does really, really well is if it finds a version that can mitigate this vulnerability, it will try to update that version for us. And on top of that, it utilizes open source community, so it utilizes the public repositories to give us a metric of compatibility, which is metrics on how many of other projects have successfully upgraded from the versions we're using to the version we want to use. And this is something I really use a lot to just get some extra sense of security. All right, how big is this update? We have semantic versioning, yes, but we all know that somewhere is a developer that can make mistake. And that was the security update. So Dependabot another feature as well, and that is version updates. So regardless if it finds a vulnerability or not, the Dependabot can actually update versions for us. So making our application a little bit less legacy for us. And I will demo everything, and there are some gotchas with this, and it's basically if you don't touch your code for many months, you can get a lot of pull requests. And there are some ways you can actually try to mitigate that. But still, very powerful functionality, a functionality that we use all the time. And then dependency review. So dependency review is basically an action, a GitHub action. where you can use this in your pull request, make sure that this is run. And what you can do there, it will basically, what you can do is put a threshold. So if I try to introduce a package that has a vulnerability with, say, severity high or higher or critical, I can actually break pull request. I will not allow this pull request to actually go through. Another really good thing is that it will actually gather some data. It will show you the licenses, and it will also show you how many updates were there to the repository. How old is this version? So it will try to help you out and give you some sense of how well maintained is this package. And this is just a simple GitHub action that you can use, put in your code, in your builds, and you're good to go. You have this protection. And I know the licensing part is also very dangerous, if we're gonna if we say it in that way. On to demo. Right, so I have prepared a repository. So I have a repository, and I've tried to mimic real world as best as I can. So I have a backend and frontend application as monorepo. Frontend is TypeScript, React. Backend is .NET, container-based, so I have a Docker file. And on top of that, I use Terraform to set up infrastructure in both AWS and Azure. I mean, this is kind of how it usually looks nowadays. So I have some fairly generic project, not that much code, but yeah, here we are. So I just created this. I did, though, turn on Dependabot some of the features. But I have only one commit to this repository. So first thing I want to do for the private repository, public ones as well. So I certain public for certain features are available for public. They are turned on automatically. For private ones, you need to turn them on. So in settings, and if I go to code security and analysis, this is where I turn all the functionality on. As you can see, I have dependency graph already enabled. I have Dependabot alerts already enabled, and I have Dependabot security updates already enabled. But everything is dependent on dependency graph. So if I try to disable this, it will actually tell me that it will disable Dependabot as well. All right, with this enabled, I already see some things. I have 4 issues or 4 warnings at the security tab, and I have 2 pull requests. So if I go to security tab, and this is where all my warnings for vulnerability, all GitHub advanced security warnings will be visible. One of many places, but this is one of them. So I can go to my security tab, I can go to vulnerability alerts, and I can see Dependabot has 4 right now. Prototype pollution is JSON5 with parse method. It's a high severity. We have affected versions and patched versions, and I can see documentation here about what the problem is, why is this a problem, and how to actually well, you know how to fix it. You upgrade the version, but you understand what is happening. And if there are CVEs, numbers, and IDs, you can actually go and visit those sites and read more about this particular problem. And as I mentioned, I have a pull request for this, and I can see it right here. And the same thing I can see here as well. So GitHub Dependabot actually raised pull request for me to fix this issue. Actually 2. So if I go to pull request, I have bump, the one that I showed you. And if I open this one, I can see this is a minor bump, basically only revision. I can see the release notes for that particular package and versions. And one of the best features ever, just some simple metric about kind of, can I really do this now? Do I really need to, if I do this, if I will to test this pull request, how much testing am I going to need? And in this case, 87% of people doing this jump have made it without the problems. And with semantic versioning being just a revision, it actually gives me some type of confidence that, okay, I can actually go ahead. So I will actually merge this pull request. Now the pull request is closed. We have one open. And we can see that the Dependabot errors are fewer. And I can do the same thing here with .NET as well. Now for the .NET part, it's a bigger jump. I can see that there is no compatibility value, and in some cases this is what you will see, because there is not enough data to actually give me a meaningful number. So in this case, I may want to do more testing before I decide what to do. However, there might be alerts here that I don't want to fix. So there might be alerts here that are maybe wrong. They do not affect my code. I mean, it's still my code. I do know how I use certain stuff. So in that case, I can actually dismiss alerts. And I need to have a reason, and I can add a comment. So I can say, for this project, risk is tolerable, and I can put in some comment, and I can dismiss it. Now I will have a log, what happened, and I now have a dismissed alert, and one less warning that is shown. The good thing to know here is they are never closed. I mean, they do not disappear, which means I can still see here three closed alerts, and that means that I can actually go on and reopen them if I want. So I can close them, but they don't disappear. They will haunt you. So this was the Dependabot updating vulnerabilities. We have also the insights. I want to show you also the dependency graph. And this is what you will find under insights, under dependency graph. And we have all the dependency for all the packages that we use. And you can drill down and get scared when you come to like 20 deep or something like that. But this is how application development looks like. So we have this, and it will also show us the vulnerabilities in this view as well. So it's a really nice way for us to actually understand how many dependencies do we have, how much exposure do we have towards supply chain attacks. The last thing I want to actually turn on is updates for versions. Now, I just updated the packages that have vulnerabilities, but now I want Dependabot to actually help me keep my dependencies fresh to the latest release. And for that, I actually need to enable that and configure it. So I need to tell Dependabot where are package manifest files. which files to actually update. So when I press enable here, it will create a boilerplate code for me. And right now, package ecosystem is empty. I can choose to have NuGet, npm, Terraform, Docker, whatever. But this is an issue. The directory goes to the root. So let's see what happens. If I choose npm here, and I create this file, Dependabot, under the GitHub folder, just push it in. If you, I know my code, so I know that there's nothing under the root, but you may actually have a hard time to actually understanding what's happening now. And there is a good way to actually see if there is a problem with Dependabot. And that is under Insights, once again, Dependency Graph, and Dependabot. I'm pretty sure it's configured, so let's see if I did anything. Did I mess anything up? No? So basically didn't run yet. I think it just need some time, maybe because of the load, to understand. But it will actually tell me in this view that it found something wrong with my file. So in this case, I already know what the problem is. The problem is that I'm pointing to a folder where there is no manifest files. And I have this in already configured. So for me to work, for this to work in a good way, so what I can do is I can point out to all the package ecosystem I use. So as I said, I have Terraform. I have Terraform in 2 places. I have a Docker in the backend, and I have and with npm as well, or sorry, NuGet in the backend, and I have npm on the front end, which is not here. So let's add it. Commit changes, and hopefully this will now it plays false. So now I can have I can see that it's checking now. I don't see any errors, and pretty soon I will start getting a pull request as well. Now I have 2, and they will be coming. So right here I can see different bumps, and I can choose actually to allow them or not. It's not always that I want to actually upgrade, depending that like all the version upgrades that Dependabot tells me to. And in that case, I have a possibility to actually communicate with Dependabot and tell Dependabot to ignore this major version, this minor version, or this dependency. So let's do this. Ignore this major version, and just to copy this. This is you can see this in the comment. So I will just do this as a comment. And you can see Dependabot has closed this bump pull request. It will not open another one for the same version that I'm specified. So that's basically Dependabot. Okay, let's continue. Secret scanning. This is actually one of the easiest things to turn on. It's just basically one click enable, and what it does, it identifies patterns as early as possible. And out of the box, there are 100 plus patterns that are included, and they are highly confident patterns, which means they are regexes that are more or less certain that they point to a specific pattern that is a secret or key or token. And you have also a possibility to add your own custom secret patterns though. Out of the box, these are the tokens that it will scan for automatically. But these are also partners to GitHub, which means that there are two different flows for the repositories that are public and the other ones that are private. So this is for public repositories that GitHub have searches for patterns that it has partners with. That can check the endpoint with. So the first thing what happens is when you do commit, it will run regex. This is for public repos. Then it will actually call an endpoint at the partner to confirm if this is truly active secret. And if it's active secret, it depends on which partner, which vendor, you will get different behavior. When I tested this with GitHub, my token get automatically revoked. So automatically revoked in this case. In some cases you will get notifications and so on. For private repositories, they never send secret out. And this is because it's private. You need to decide for yourself, kind of maybe you want to have it there. Maybe that's by design. It's not best practice, but they don't send it to the vendor. And custom patterns, I will demo this. It's quite simple. It's basically regex, and I can generate 500 custom secrets or search for 500 secrets on organizational level and up to 100 on repository level. So you have this possibility you can use. And also push protection, which means that I have possibility to actually block commits coming into my code if they contain secrets. So I can protect my Git from secrets, so to say. And I will show that. Basically, you get the message. You can bypass, which means when I press this button or if I go to a link, I will be able to bypass it for up to 15 minutes. And after that, you need to bypass it again. So secret scanning, the same thing here. The first thing I need to do is enable this. Back to the repo, go to the settings, code security and analysis. And now I will turn GitHub security on. It will tell me how many licenses I'm going to use. I already used this in other repositories, so nothing changes. So I will enable this. And now I can see secret scanning automatically enabled. And this is organizational setting that we have set that it automatically include push protection. And I can define custom patterns here. And this is what I'm going to do just for demo. So I will create the custom pattern. Name my pattern. Then I can write it as a format. So in this case, I will just do something simple here. 0 to 9 and 4. I have more options. So I have a certain regex before the secret. I can search for that, and also after secret to narrow down what I'm looking for. I can also add additional match requirements, and I can chain them up. In this case, I just want to keep it simple. This is a simple pattern I want to use. So next thing, what I need to do is I need to test my string. So no matches, which means one match. Cool. And this is no match. The GitHub is a bit slow today for some reason. So it's tired. It's Wednesday. Could be that. So I will do a save and I will do a dry run. And with dry run, this is not published yet. So I can do a dry run on this repository, on the Git history, and you can see if this is something that already exists. And because the repository is not that large, it will actually complete this with no matches found. Cool. Next thing I can do is publish the pattern, and now this is active. So just to showcase this, I will go to my README file, just a basic commit, and I can do commit changes. And I should it's a secret. I don't have a push protection. So right now I have this in my repository. I can go back to security settings. It's so slow. Sorry, guys. Code security and analysis. And if I go to my existing pattern, edit it, I can actually change to have this this pattern push protected as well. It takes some time, so I will jump over this so I can go to code scanning. So the code scanning, as I mentioned before, it uses CodeQL to search our code for vulnerabilities. And it's a true SAST tools. And what it will do, it will integrate the result directly under a security tab. But also, if you have a pull request, it will actually show in the comparison in the pull request. If you go and look in the changes, it will showcase what the problem is. And because of CodeQL, because the CodeQL is open source, there is a huge community and a lot of queries out there from organizations that you can use. So out of the box, you will use default one, which is constructed of queries that are generating very few false positives. But you can increase that with different packages, and also you can write your own queries. So how does CodeQL work? So it's a semantic code engine, and it works in a way that it will look through your code. If code needs to be compiled, and it will monitor that, and it will build database from your logic. And because it builds a database from your code logic, it does take some time in some cases. You will be able to basically do queries against it. It's like you do with SQL and the database. But this language is CodeQL is constructed for querying syntax. And then when you run those queries against it, you will get results, and the results will be uploaded to GitHub. And those queries are quite easily changed, but you need to understand how you write those CodeQL languages queries. this is not limited to CodeQL. So if you want to use other tools as well, the GitHub has a marketplace and integrations to different other tools. And basically, if you use them, you can collect all the information in the same manner as you do with CodeQL and rest of GitHub on security features. So all other scans, if you want to scan containers, if you have some specific language that is not covered by CodeQL, everything can be included that way. And also, this was a question I got previously just before the session. If you use other CI/CD tools, but use GitHub, you can still use CodeQL to query those. And you can then send information back to GitHub. There's a question. Yeah, so how you do that is there is something called CodeQL CLI, which means that you can actually trigger CodeQL regardless of what you use. No Dependabot. So it's only for CodeQL. Yeah, for the Azure DevOps, GitHub Advanced Security is coming. So that will be one thing. Thank you. I forget. Which is really a feature many were looking forward to. And of course, if you have other tools that can upload SAR files, everything can be uploaded to GitHub because of the rich API they have provided. So last demo part. And I will go to my repository, to settings again, to code security and analysis, and I will go to code scanning. So right now I need to set this up. And the one thing I will do is actually go to advanced and set this up. GitHub will scan for languages used and will suggest to actually include them in this scan. And you can see it supports C++, Go, Java, Python, and Ruby as well. But in my case, I both have C# and JavaScript. And what it does, it initiates CodeQL, then it triggers auto build. And this is an action that will actually try to build default build method for the language. And at the end, it will actually perform CodeQL analysis. And this will include updating or sending information back to GitHub. So in many cases, what I can do is commit this. And what I can see, I have now CodeQL workflow that runs. And let's look at my code. There's a little bit, it's not that much time left, but I want to show you. So in my controllers, this is just .NET, I have this controller which gets an ID as a string. And right now it doesn't do actually anything with it, it just returns some value. But let's say that I uncomment this. It's easier to uncomment here. Just grab it. So I will have another action run. And what will happen? What I want to show is because the code was commented out, it will not get it the first time because it doesn't affect me. It doesn't affect runtime. But the second time, it will actually find it. It will alert me that I have a SQL injection here, and it will point to the exact line where I'm doing wrong. And this will actually get this problem even if I chain methods, chain classes. So it will follow it all the way through the hierarchy. I can take, this is the last thing I want to show. So I can take some question and answer until that thing returns, and I can show you what it has shown. Yes, I have a question. So for the public repository, it's free. For the private repositories, you need to have a license for GitHub on security. And Dependabot is still free. Yes. And if you want to know more about GitHub and all the features, my colleague Magnus Timner and Matthias Olausson, they are going to talk tomorrow about applied code spaces in GitHub. So, and any questions, just keep them coming.
What do you feel about this tool compared to other similar tools, like, for example, Sony?
Interesting question. I get that a lot. So they scan a bit different set of vulnerabilities. So there are some you won't get the same warnings. In many cases, yes, but there's some differences. The GitHub creates a far less false positives. That's what I've seen. So with the default set of queries that you turn on by using this, you will actually get few false positives. But in Sonar Cube or Sonar Cloud, you can actually get quite many. So see if I have returned, and now I have code scanning warning as well. And if I open this up, I can see SQL query built from user control source, severity high. So slow. We have it, yeah. So it will show me the file. It will show me exact line, and I can open it up, and it will show me the path through the code. And of course, I will see recommendation, I can see example, and I can read more about this error. Yes?
Can it even detect the endless loops or division by zero or stuff like that?
I think so, yes. I think so. I need to check, but based on how you write your queries, I would say so.
There is this extended thing you can turn on as well, because this is mostly security stuff.
Yes, there are different set of queries, and there are 4 from GitHub you can use. So this was the default one, which generates very few false positives, but there are other ones that include like code quality and stuff like that. So you can have different type of scanning there as well. And also here now I have a code QL added, but I can add another scanning tool here as well. And this is the list what I have to choose from. So I can just let's say I want to do ESLint. I can configure, and I will get the boilerplate that I can edit a bit, and when I commit this will be included in the security tab, warnings, everything. So that's it. My simple application has like what, 3-4 problems already. It's and the front end is basically create React app, honestly. So yeah, the dependencies and what we have to work with, it's actually scary. we have a lot of code that we know very little about. Yes? It will work in case you have a large code base. You may not be able to run this as a pull request. But regardless, when this action is created, you can still have it as let's see here is as a scheduled cron job. So if you have a large code base and if you have intricate code base, that could not be an issue. So it could take a while. But in that case, I mean, you can still get it by doing the cron job and doing this nightly. Not as good as peer, but still, I mean, you get the protection.
You also mentioned that we can use custom tools, but do we have to have them in the marketplace to use them?
No. So as long as the tool can actually export a Sarif format, so Sarif is a JSON file format, you can upload that format to a GitHub API. So if you upload that file, it will be included. So I know, like in OWASP, there is a DAS tool called Zap. There is a pull request there waiting and to be approved that actually enables Zap to export Sarif as well. In that case, you could have that included in the pipeline and have that report issues as well. So this Sarif integration is really, really good because it opens up so much possibilities. And I'm looking at this holistically, like if you talk DevSecOps, even DAS tools, even other type of checks, if you can feed everything to GitHub, you will have everything in one place. All right, I don't have anything else. Thank you so much.